So, Mr. Hall was very tired yesterday.
Like in here yesterday?
Yes,
You were not tired.
I actually was.
You had more energy than all of us yesterday.
That's because I was pushing through. I was very tired. I know you
Still
were.
tired.
And you were so tired that I'm blaming you. You allowed Mr. Hall to make a mistake.
What did you do?
And it took me till 8th period for it to dawn on me. And I went, oh my God. I went back and watched the video, and yes, Mr. Hall made the mistake. And you allowed me to do it. So, to make sure we're all good, I want to go back through this again on I day.
Yeah, I was like, we don't have to.
Yes.
How does that work?
So I want to go back through I day, and I'll rush through and get through to the point towards the end so we can make the correction. And I'm going to spell it out. Make sure we're all on the same page so that there's no confusion. Okay? So, doing I day, IO3 negative, and I do have your polyatomic ion list that we'll give you here shortly. So, we start with iodine in the center. Draw the skeleton with the 3 oxygens. And then we give everybody a full octet. The oxygens have a bond, which means that gives them 2 electrons. They want 8, so they need 6. So we give each one 3 lone pairs. Then iodine, it has 3 single bonds, which means it has 6 electrons and it needs a lone pair. So just stick a lone pair up there. I will say this, I noticed a lot of people are making that mistake. They're missing the iodine. Even though iodine's in the center, it does not mean it has a full octet. You need to check those center atoms. Make sure they have full octets as well, unless they are rule breakers. Okay? So we go to count up, see how many electrons we have to show. We have 1 iodine, 3 oxygens, 7 valence electrons for iodine. We know that because it's in the 17th column. Yes? 1 times 7, 7. 3 times 6, because each oxygen has 6 valence electrons. We know that because it's in the 16th column. 3 times 6 is 18. But then, we have this charge to take care of. And remember, we're talking electrons. Electrons are negative. You see a negative, do the opposite. We add. So we'll handle that charge here, and we will add another one. So 7 plus 18 is 25. 25 plus 1 is 26. So I have to show 26 electrons. Everything works out. If you check this out, we'll show them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Showing 26 electrons, which means we don't need a double or a triple bond. Here's where the mistake came in. When we check the charge. So I want to make sure we're clear on this. I said this backwards yesterday. I know it's weird, right? Like a teacher admitting, I made a mistake. It's all y'all's fault.
It's what you need. That's what you have. Go through it.
No. When you're checking charge. This is the key. When we're checking charge, first and foremost, bonds count as 1. I think you're doing a lot better when I tell you just count the bond as one and I don't tell you be a surgeon and stick the electrons out to the side. So just count the bonds as one. Second, when you're calculating charge, here's how you're going to calculate it. The top number is the number valence electrons from periodic table. I told you backwards yesterday. Now I know before break I told you right. Yesterday I told you wrong. You will subtract from this the number valence electrons showing. This number is where those bonds count as one. So what I'm saying here, bonds count as one, so let's look at let's look at this oxygen here. First number is the number of valence electrons off the periodic table. How many valence electrons does oxygen have? Periodic table, 6. That's the first number. So it's 6 minus how many we're showing. And I'm saying bonds count as 1. So 1, 2, 3, 4, 5, 6, 7. 6 minus 7 gives you -1. That oxygen is negatively charged. If you go back in your notes and you find what we said yesterday, change it. That's what Mr. Hall tell you. Mr. Hall make mistake. Mr. Hall so sorry. I'm still coming back from break.
That's just how I can call you from we were working in the lab. That one will look like it will.
I think you'll be alright. Alright, this oxygen here, what comes first? 6 minus the 7. That's negatively charged. It's going to be the same thing over here on this oxygen. Then go to iodine. This is where it'll change for you. Look at iodine. Look at iodine. What number comes first?
7.
Why do you get 7?
17
Because iodine's in the 17th column. So it's 7 minus what you're showing. 5. Which is positive 2. That is proper Lewis structure for iodine. Now I know that because I'm going to check myself and add all my charges up and I'm left with a -1, which is what it should be, not a +1 like I left you with yesterday. I didn't check myself.
But I thought so far, I was like, hold on, that's not what we're doing. We might continue.
That's next. I wanted to go back and fix this. I want to make sure you fixed it. Is there any questions here? Because a lot of y'all are just like blankly staring at me and being quiet.
We're gonna do something with that.
Because we're doing sulfate. That's where I let you off yesterday. Yeah. No questions? Okay. So let's go back then. had started on sulfate yesterday, and I gave you some time to try it yourself when we had reached a certain point. So I'm going to run through sulfate. So you look at sulfate. Step 1, find the center atom. It's sulfur. Step 2, we draw the skeleton. So we got 4 oxygens, need 4 single bonds. Then at this point, I give everybody a full octet. Now here's the key. Because sulfur will break the octet rule, doesn't mean you automatically have to break the octet rule. Don't always look for that to happen. So we're going to start giving everything a full octet. We'll start with these oxygens. Every one of these oxygens have a bond. The bond counts for 2 electrons. So I have 2, I need 8, I want 8, so I need 6. So y'all think we're going to have school Friday?
We probably won't have it tomorrow either.
We will. It's coming after school. We'll be coming there today.
I say we get released early, and then we don't
I
have school.
hope because I hate this place. I do not want to be here.
No love.
No, I think there's like a broad understanding of that statement, though. You can hate the place, like the people. You just don't like what you're doing in the place.
Exactly.
I like
what I
this
did in the
class.
place. I don't like that.
But everybody gets something else.
Alright, so when you look at this point, everybody's got a full octet now. So now we step into calculating and seeing how many electrons we have to show. So we got sulfur, we have 1 of, we have 4 oxygens. We're going to multiply those by the number of valence electrons they have based off of the periodic table. In this case, it's easy because sulfur and oxygen both are in the 16th column, which means how many valence electrons? 6, very nice. Four times 6 is 24, but I have this charge to handle. So on that charge, that's a -2, so I subtract 2, right? What did I do?
You had to.
Why?
Because it's a negative and you do the opposite.
It's a nice way to remember it. Because we're dealing with electrons. Electrons are negatively charged. If it helps you do the opposite of what you see up there, then by golly, do it. So 24 plus 6 is 30. 30 plus 2 is 32. Actually, 32 electrons. So let's count up. I'm showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I'm showing 32, so I'm good to that point. Now, we look at charge. So let's start looking at charges on here. So let's start with this oxygen first. What number comes first? 6. Number from the periodic table, right? Right. Wonderful. Everybody moves like their personality over the break, or y'all still just like on a break hangover, or?
Yeah.
Okay. So, minus what? 7. So, -1. Every one of these oxygens have a negative charge. Right? Okay? So let's go to sulfur. What number comes first for sulfur? 6, because of the number off the periodic table. Minus what we're showing? 4. So plus 2. That's positive 2. So here's the thing. This is why I love sulfur. Sulfate, sorry. I don't love sulfur, I hate it. I love sulfate. You have charges there. But the key is, can you get... Oh, thank you. if it's possible, this is where we want to take away charges as much as possible. So is there a way we can add something in to take away charges? The answer is yes. We can add in a double bond. But we just ain't done there because remember, sulfur's a rule breaker. How many bonds will sulfur form? 6. Very nice. It's like pulling teeth with y'all this one. So we gotta get 6. So I'm gonna add a double bond here. Add a double bond there. Where am I gonna take it off from?
The left and right, where you put the one.
Take you left and right where we put bonds. Now take that off. Take that off. Am I going?
No,
Why?
you gotta check charge.
Check yours. Okay. So let's look at these oxygens. It's got the double bond. What number comes first? What number comes first in checking the charge? 6. Thank you. Why? Because it's 6 off the periodic table. Now look and see what number comes next. What we're showing. 6. 6 minus 6? 0. That no longer has a charge. We're doing away with charges. That's what we're trying to do. Is there any reason to check these oxygens? No, I didn't change it. This oxygen's the same as this one, right? So that charge goes away. Are we done? Why? Check sulfur. We change stuff. So look at sulfur. First number. Because it comes off the periodic table. Next number. Because I have 6 bonds. So 0. So what's the charge on sulfur? 0. It's neutral. So take it away. So do I still get the -2 overall charge? But there's less charges in sulfate, which means this is more stable. Now am I done? Why?
You gotta do resonance structure.
Resonance structure. You gotta love it, right?
I just marked out my old one from yesterday, and I thought, oh wait, I actually done it right, so I'm writing little notes in. Never mind, that's right.
In college, in my math classes, I did like the thing that people call me nuts for. I took all my notes and worked all my problems in pen. You know why? I put an X on it if it was wrong, but I could still see my mistakes. I would be like, don't make that mistake. All right. Don't do more work than you need to. Double bonds are off to the side, so now what do? Just go to the top.
90 degrees.
The oxygens that have the double bonds on them only get 2 lone pairs. And the oxygens that have the single bond get 3 lone pairs. Dalton's right, the oxygens with the single bond have the negative charges, and everybody else is neutral. Am I finished? Yes, that is the properly drawn fluid structure for sulfate. Questions?
Are there more resonance structures? Are there more resonance structures?
Because these double bonds are going to go as far apart as possible. So this one won't go here and that one won't go here because they'd put them too close. It's a very good question though. Mr. Hot have a gift.
I think I'll wait for next question.
What?
I think I'll wait for next question.
It's okay, I give it to you now.
If you say so. Yeah, I'll take it.
So I hope they got rid of this and never went away.
Oh, I'm supposed to sing Valentine's Day songs?
Yeah.
You're here.
I didn't know that.
Nothing. That's all right. I don't know what's about. I don't know a single word. I do not know a single word for that song.
You just had so parts. Oh,
Okay, listen to me before you freak out on me.
I've already figured out.
This table is the same as this table, except the table on the left is in alphabetical order based off the name. The table on the right is in alphabetical order based off of the chemical formula.
So which one?
They should have them.
Who's saying
There should be an answer right there. You wait for everybody to get there.
Whatever was hard to settle, so you could doing like big kids.
Pretty much. So what I'm getting ready to tell you should not terrify you.
And it probably will.
Probably. You don't have to know every one of these on here, okay? I am going to highlight the ones that you need to know, and I'm going to send a picture out on Remind. Does everybody hear me?
I would cut my highlighter out ready to go.
Yes. Very good. Very good. I want to focus on doing something else that I think will be productive for the class because of the quiet and the looks that I'm getting in the room. So, I will send you the picture of what you have to know, okay? Understand, right table, left table are the same. So don't freak out on me. With these, you have to know the names, and you have to know the chemical formulas. Guess what is a part of that chemical formula?
The nomenclature of it.
No. The charge.
Oh,
You have to know the charge.
Why am I not positive?
There is.
There is like one.
If you miss the charge, you miss it entirely. I know that sounds cruel, mean, and you think I'm the devil.
But when there's only one, you gotta be able to do it, really.
You have to know it because what's going to happen is whenever you get to nomenclature, these charges matter. Because it's going to tell you how many are there. So you have to know it.
It all matters.
What?
Do they matter as much as units?
Yes.
Maybe even more.
I feel like this
Wait.
quiz is going to be a repeat of the element quiz.
I did pretty good on my element quiz.
I will be honest with you. Do you remember the element quiz how I had to break up? This is going to be the same thing. It's going to be a table. On the left column, I'll have names. On the right columns, I'm going to have chemical formulas. So I will trade back and forth.
So this quiz Friday.
No,
No.
don't even know.
Friday, that's
There's no way I can memorize this.
Welcome to AP Biology.
We'll say Wednesday following.
That's why I didn't take it.
I didn't sign up for it.
Thank you. Thank you for not taking it.
You're very welcome.
Literally.
Let's be honest. AP Biology is not like this class. But it's okay because you're still learning from it. Because when you get to college, and you have all these PowerPoints and all this information, and you get someone like, I can't remember the guy's name, I didn't have him, but he was a biochemistry professor at Marshall. He said he wanted to be the next John Hubbard. And John Hubbard was the Organic 2 professor, which was the guy that you pretty sure that you would cry. Like, he made kids cry. He didn't care.
You make me.
So he had done, he wanted to be the new one. So that's fine. Guess what he got?
Fired.
No, he got to be the new one.
I was gonna say promotion.
In his biochem class, he would teach you 6 chapters of material, then test you. And in the whole 6 chapters, there's chemical reaction, chemical reaction, chemical reaction, and processes throughout all of it. You have to know every one of everything in all those 6 chapters. But he asked you one.
One question?
One cycle. So it would be like you would learn all these cycles, and he only asked you for the Krebs cycle. And you have to know the Krebs
I
cycle.
know what the Krebs cycle is. You got the Krebs cycle and the Calvin cycle. My biology teacher taught me that. He don't work here anymore. He left. They're all.
So is this Friday a live day?
Yeah.
No, I will not be here this Friday.
Mr. Hall, we don't have school next Friday.
We can take a Thursday.
Why do we not have
It's
school next
a
Friday?
professional learning
Oh,
day.
yeah, we got.
For what? What do I need to learn?
That's Martin, we get the Friday.
Then it's Martin Luther King
We
Day
can
next,
take-
Ah!
so we don't have it on Monday either.
We could take.
We could do it that
We
Tuesday.
can take it the next Friday.
How about we take it Tuesday?
Or Wednesday, because Tuesday we're not at all. I'm good.
Not like next week. Like next week.
Fine.
No, John.
I might be dead
No. How about we take it to Wednesday
Thursday's
after
okay.
Martin Luther King Day?
then. Thursday's
Yeah,
okay.
21st.
How about we just take it now?
Yeah,
That's a
we're
good
gonna
idea.
take it now, and we don't even know what's on it though.
And the second 9 weeks.
Yay.
Sorry, Mr. Hall, you have to have a professional learning day.
Dumb.
We have to come to school, so you.
Hey, at least you get a 3-day weekend.
Dumb. Yeah.
Tell Martin Luther King Jr. that, not me.
No,
That's not my fault.
Polyatomic Ion Quiz will be Thursday, January 13th. Sorry, I was gonna make it 14th, but you know, gotta have a
We could've
professional
not
meeting
told
day.
you. We
What's
could've-
wrong?
we could've
The 21st, the last day of this semester?
Sure, I don't know.
What if we show up anyway? What are they gonna do? Tell us to go home?
Yeah, what do they do? Like, what they do?
What if we show
Yeah,
up anyway?
21st is the end of the 21st is the end of the first semester.
I mean, what if we all meet up here at like 12 o'clock and take it in?
What are they gonna do?
Not everybody will do that.
Mr. Hall, I got a question.
Yep.
About that test that you dismissed or whatever before break, is that like this? Like, did it just disappear or is it going in as a grade?
It's going in as great.
A 0 for you
Probably.
for asking the question.
Okay.
Nah, I don't. There's one month I don't know if anybody born
What? I
in.
guess it's June or not.
We have a test.
Yeah,
this morning.
June, but a lot of them born in June.
Let's see.
Something's gonna die.
All right, so, ladies and gents, we, as you guys are aware, I will not be here tomorrow. I will not be back until, you will not see me back in this room until next Tuesday. So, you guys be good. You are taking the Polyatomic Ion Quiz.
So we're not.
What if you're not here?
Day Monday? It's Thursday.
This is heartbreaking.
It's Thursday.
Huh?
It's Thursday.
Are you kidding me? Oh my Jesus, that makes me have 5 tests today. I'm one of people.
So, listen, we are, you're going to take that quiz. It'll be your last quiz before the end of the semester, okay? It's straight memorization, but I'm stressing to you, know those charges. If you do not know those charges, you are not going to do well on that quiz.
Who has it studied?
I sent a picture with it on remind. If you need a polyatomic ion sheet, you need to tell me. We can get you one.
What's sulfate?
Pictures on remind of which ones to know.
What's sulfite?
Two.
See, I've already learned a trick. If it has an I in it, it has a sub number 3.
The major rule you can follow, except for a couple,
Study.
like manganate and permanganate don't follow this rule. But if you look at it, go to chlorate. What's chlorate?
Ain't nobody.
O
C8, ClO3, -2. Okay.
ClO3 negative. Perchlorate. Per. ClO4 negative. You added an oxygen.
You have this off the top of your head.
Chlorite.
You take away one.
Take away an oxygen.
Because it has an I.
Hypochlorite.
You give another one, because hypo means high.
Not. No. You take another oxygen away. So you can pretty much follow that trend. But study, study, study. If you're waiting to study the night before, you're going to mess up on these charges. This is where you should make your note cards, and you should start rolling through them now. Okay? Yes. My lovely sweet wife will be here to give you the quiz. But my lovely sweet wife has been informed from me. I expect those quizzes to be waiting on me.
So, in which minutes we'll have you further with laughing at us every time we remember this?
What? Hey, don't ask her for help, by the way, because just because she's married to me doesn't mean she knows what I know.
She might know the thing.
She might.
It's not about that.
That goes right over
What's she
there.
talking
She
about
don't
the
listen to
What's she talking about the substitutes like? I don't know this one. Honey, let me go look at the answer key. And then
Thursday.
it's FL, I don't know.
That ain't gonna happen.
What if I give her $1?
Not happening.
$2?
No.
That's all I got.
You have to buy your food.
Alright, so besides that,
And thanks to Mr. Hall's TikTok, we already know what to drink.
What's she drink?
I don't know. Do you remember?
so we are,
I think it's a white cream.
I have you a Lewis structure practice sheet for you tomorrow. Besides that, on top of there is an electron dot diagram practice. Electron dot diagrams, so much fun. So I'm going to teach you how to do electron dot diagrams today. I'm going to be honest with you, I'm about Lewis structured out. So whenever I come back, if you have questions on Lewis structures, I'll answer them. Besides that, I do not feel like doing another Lewis structure today. So let's look at the electron dot diagram. All electron dot diagrams is literally the chemical symbol of the element and dots representing those electrons.
Oh, God, they're giving blood.
Sure, I did that.
I'm saving a lot.
That's wrong, baby.
Where did I go wrong?
Alright, so there is a certain order things have to go in. So let's put X up here. X is filling in the place for our chemical symbol. I'm not saying that is anything. I'm just saying that's the variable. That's where the chemical symbol goes. So then there's a certain order the electrons have to go in. This should not catch you off guard. The first electron, top left. Second electron, top right. Now I know you think that it's going to go 3, 4. No, it's not. Yes, it is. So 3, then 4 is down here.
What?
Then 5.
Are you sure?
What? Why, Mr. Hall? Well, let me help you kids. You remember this?
Please stop sounding like Barney. I hate it.
It's not Mr. Ames. Look at the second you done that, I was like, I want Mr. Ames.
Hey, he didn't know Mr. English thing though every morning.
First electron, boom. That was number. That's that. Second electron, boom. In the same orbital. Then we get to P watt. There's third, fourth, fifth. Where's the sixth one go?
It goes on the first one. There you go.
So here's 6. There's 7. There's 8. If you can do this, you have electron dot diagrams. It's that simple. Let me show you. So let's take an element, nitrogen for example. You write down the chemical symbol. Chemical symbol for nitrogen's N. Then you put dots, however many valence electrons nitrogen has. How many valence electrons does nitrogen have?
5.
Wow.
How do you know it's 5?
Because it's in the 15th column.
It's in the 15th column. So 1, 2, 3, 4, 5. Done.
That's it.
That's it.
I don't like it. Did you forget to text her again, Mr. Hall?
Done.
That's an uncle's dog sound like.
What?
He has a French bulldog.
All right. But speaking of dogs, how about Georgia last night? Wow. They called that
What happened to Georgia?
the national championship.
Did they succeed? Secede from the north? I don't know. I'm on the Civil War right now, so.
No one doesn't know sports, okay?
I thought we were talking about Game of Thrones.
What happened to Georgia?
I think everybody's pretty like-
I thought we were talking about Game of Thrones.
I thought Mr. Hall posted something on
About
Facebook
silicon.
about like somebody losing. I was like, what happened? What's up that happened?
Listen, the day Dalton watches sports will be the day the world ends.
Oh, really?
It's doing any better.
I don't know where silicon is.
14th column.
Oh, it's in the 14th. Oh, no. Oh, it is.
Dalton.
OMG, that's so cute.
This is some 18 here, I'll tell you.
Sodium.
Ooh, blue one.
You have now learned how to do electron dot diagram.
Alright, can we start it now?
Yeah, because I got like 5 tests today.
Please.
No.
I'm about to have a 6th one on Thursday.
You really looking for some
Can we have a police study for like chemistry?
Okay.
You don't know which one's to study? Elijah, you don't know which one's I'm to study?
What all of them?
Oh, horrible.
No.
No, you don't study any of the ones of hydrogen.
The whole
Is it
left
all of
column. Look on
The left and right's the same. It's just in different alphabetical order.
I'll give it to you.
On remind, there is a picture.
I'll have to go to Paul when he studies with Paul. 2 rows.
All right, so I introduced this idea and I just briefly brought it to your attention. Today I want to talk about polar and nonpolar covalent bonds.
Did you say non-polar heads when polar tails?
What?
Did you say fatty acid chains? Hey, see, we're learning something.
All right, so pretty much the way you look at these to determine whether you have a polar or a nonpolar covalent bond is the difference in electronegativity. So you take the difference of it and it's very simple. You never end up with a negative number. So the difference will either be 0 to like 3.3. So don't ever end up with a negative number, always put the biggest number first. You'll see what I'm talking about here in a second. So the first thing, let's talk about nonpolars. These ranges I'm going to give you are debated. So these ranges are debated. They can be debated very simply. Others disagree on certain ranges and stuff that it needs to be, but it doesn't matter as long as you fall in this range. So nonpolar covalent bonds, the difference in the electronegativity from 0 to 0.4. And then we have polar covalents. Polar covalents, they got a range of around 0.5 to 1.4. It's where I like to do the cutoff point, but they can be different. So, when you're looking at these, great examples of your nonpolars. You remember that trick Mr. always keeps in the back pocket?
Your 7 diatomic.
Diatomics.
Oh, really? I mean, I was just testing everything.
Diatomics are a great example of nonpolars. Remember, if I use the word like oxygen. Oxygen exists in nature bonded to itself, so that means O2. So whenever we do one of these, look at the Lewis structure of one. I did the finished product. I just didn't go through the rules. I just did it really fast for you. So here's the Lewis structure of oxygen. Bond to itself in nature. This is how it sits.
Imagine being that self-centered to be bonded to yourself. Chemistry jokes.
And it's very stable. Okay?
Why do you scream at us?
I didn't scream at you, he barked at me.
So,
My chicken barks.
this is all about stability. So, nonpolars, what they have is this equal sharing. Because remember what covalent bonds are. Covalent bonds, they share electrons. So in nonpolar bonds, they're sharing them equally. Okay? It's like a good relationship. You know? You're both working together. Their success is your success is their success. The flow is in harmony. And then you go to polar bonds.
And they're like my parents. They're divorced.
Polar bonds? No, that would be breaking the reaction.
Oh.
We're breaking the bond through a reaction. Polar bonds, you always have a bully. Always got one. Best way to describe this, and for some reason, teenage students always grasp this idea. The abusive relationship.
You said for some reason, well, look at today's society.
Leave it alone. Don't name names, kids.
Toxic people.
No, we can't name names this time. Remember what happened last time?
I don't have any names.
You named them.
Dalton,
Your family out
Dalton,
last time.
you're in timeout. Just because I know you're going to rub it.
No, actually,
Yeah,
there's
last
nobody to
time you ruined the
say.
video. Stop.
It wasn't me, it was Charlotte.
All right.
No, it was his parents.
Oh, yeah, it was.
You don't do really.
Well, let's go here for a second to show you. Okay, what's the electronegativity value for oxygen?
3.5.
He keeps shaking his watch like he's in trouble or something.
No, it's,
Trying to make sure it's microshift.
You get text on a Fitbit?
I can give them. I just can't text back. That's just interesting because my wife just texted me that the teacher that she's there to sub for, another sub just showed up for that teacher. So it's very interesting.
Hey, I get paid to walk around the hall.
All right, so 3.5 minus, what's the electronegativity value for what we bonded to again? Oh, yeah, oxygen. What's the electronegativity value?
3.5.
Zero. So, really equal share. I want to show you a perfect example, one of my favorite examples of a polar.
There.
How'd you get 3.5?
Up here, I'll tell you.
The little tiny number in the corner.
On the bottom right there. Yeah, it has it labeled up there.
Yeah, it's hard
I
to see.
get to set the
Ah,
okay.
okay.
Why are you screaming at me?
Why are you screaming?
Only the color is bipolar.
It is hard to
You've
see.
been talking to him. You're like, why are you screaming at me?
Okay,
Watch it language.
one of my favorite examples.
Well, you don't remember polar is bipolar. That's how we're gonna.
Because bullies are bipolar.
So shocked.
One of my favorite examples is everybody in this room, we have to have it.
H2O.
But it also kills people.
Salt.
Sodium chloride, or potassium chloride.
Yeah. Salt can kill.
You cheating.
Hydrogen.
Dihydrogen monoxide.
Is that really, is that the chemical name of it?
Yeah,
Dihydrogen.
as a common name of water.
Dihydrogen monoxide.
Agua.
So,
That's easier to say.
You never seen the movie Laura?
nah,
Such a good thing.
I'm just shocked that you actually watched the movie I watched.
I like cartoons.
That's all Mom watches.
He's that kid that's like 30, that'll be 35 and he's first in line for like the new Paw Patrol or something.
I may or may not be going to watch the new Thing 2 Friday. May or may not.
Have you watched No Way Home?
Huh?
You watched No Way Home?
I know how to get home.
Yes.
He looks at, what do you miss that?
No, I really am getting ready to watch a Marvel series. I gotta see it. What am I watching? I don't know what I'm watching.
I think the funny thing is I watched a TikTok of a teacher that was talking about classroom management the day after a new Marvel movie releases. He walks in and everyone's going nuts and they're screaming and they're loud. It's like, all right, class, so we're going to start. All right, so we're starting. Hey, we're starting. And they just keep screaming and keep getting louder and louder and louder. And he goes, if you don't shut up more, we'll spoil No Way Home. And you hear a pin drop. And I'm like, that's hilarious. Hey, anyway, so let's look at this polar bomb.
My dad spoiled Harry Potter. I swear.
So here is the Lewis structure for water. Now, we're going to look at these bonds. So we're just looking at one of them when we look at this. So what's the electronegativity value for oxygen?
3.5.
3.5 minus, what's the electronegativity value for hydrogen?
2.1.
2.1. Those kids gave me 2.0 yesterday.
I lied to my eye doctor so she'll give me a stronger prescription so I can see better.
Why do I not put that past him? Like at all?
That's why I can
You
see
know,
better.
that's not a good idea, right?
It just makes it worse, really, but.
Oh, you really did that?
I would not put that past Dalton to go there and be like,
All right, you're right, it's 2.1, but yesterday in 8th period, they gave me 2.0, so let's say for some freak reason you get a periodic table and this is 2.0. I'm doing this for a purpose because I'm getting ready to ask you a question that I hope you can answer, because if not,
well, what if we
I'm
can't
going to yell
answer?
at you.
Well, yell at Dalton, that's probably his fault.
So you get a difference of 1.5.
You just feel wrong.
Well, that's a problem.
Oh no, our hydrogen is broken.
So you get 1.5. What type of bond is between hydrogen and oxygen?
Single bonds.
It's a single bond, and it's a single covalent bond. Here's the question. You get 1.5. Excuse me while I get comfortable. It took them a while yesterday. So, question. How do we determine if it is an ionic or a covalent bond?
Take the charge. Look at the periodic table. Ask you.
I'll motivate you. And when I motivate you, listen to me clearly. If you look at me and tell me I said this, then I'm going to look at you and say you weren't loud enough, I didn't hear you. So if you think you know the answer, be loud. I have 5 bonus points waiting for the person that can answer.
Oh my God! Where's my binder?
Ask the question again.
How do we determine if we have an ionic or a covalent bond?
Is it because if it's a covalent bond, it'll fall between those numbers?
Nope.
If it doesn't, it's the other? I don't know.
Y'all would be trying to have been worried about those.
Covalent bonds want 8 valence electrons.
Nope.
Oh my God,
They all want 8.
Because ionic bonds are stronger than covalent bonds, so there'll be more bonds.
How does that got anything to do with it?
So there's be more.
Covalent bonds don't lose or gain electrons.
Is it good? Never mind, I don't want to
So
say.
you must see it close, you did say no, so keep going.
Valence.
Have you told us this before?
I absolutely have told you this before. I've taught you this.
Well, it was this, like, have you even
Oh, yeah.
I don't remember.
Well, I said you find out.
Is that how they're optionally charged and attracting each other?
That's ionic bonds. How do we identify if it's ionic or covalent?
Gaining and losing or sharing.
Energy levels.
That's describing them, but how can I identify?
Energy levels.
No?
Uh,
Well, at least this ain't bad. You all need periods. Same boats.
The structure.
I can see Desiree right now, we're just sitting there.
It's not their structure. No.
Is it valence electrons?
No.
All I see is nothing but like.
The sound of pages turning. I love it.
Why do I never write down?
Because of their form between.
What particle duality?
What?
What'd you say?
Form between metal and non-metal.
Is it it? Was he right?
He's close,
That little
I'm gonna tell you
staircase.
this.
because,
I'm giving 5 bonus points. I need more detail.
Say what you said again.
because,
Ionic bonds form between a metal and a non-metal on the periodic table on a little staircase. Yeah.
Ionic bonds form between 2 things on the staircase and covalent bonds.
Who said the covalent part?
Shaolin.
needed, I'm talking to you.
I don't know what you said.
We went half feet on that one.
Cause he said
Shaolin, what'd you
how
say,
ionic
Sadie?
bonds form, and I said how oil.
Yeah, we went half feet.
Shaolin, will you please say it again?
What?
No, like seriously, I want to know now.
Covalent bonds
No, don't tell
form-
them.
No, I want to know now.
Alright.
So,
How do you determine if you have a ionic bond?
That's your
form
part,
between a
right?
metal and a non-metal.
And how do you determine if you have a covalent bond?
They form between 2 non-metals.
And how do we determine if it's a non-metal or a metal?
The off-ball principle.
The staircase.
The staircase.
So you said.
What's to the left of the staircase?
Non-metals. Metals. Transition metals.
Hold on.
Transition metals. They don't come out of the rules.
Hold on. I have
Transition
this
metals.
somewhere.
So to the left of the staircase are
Transition metals.
metals.
I said that. And you just looked at me.
No, I said, what's to the left of non-metals?
No. Check your phone.
It is. Oh wow.
To the right
Non-metals.
is non-metal.
Sounds like I'm a poet express.
Aluminum right there.
Right. Left.
I'm grabbing this and going.
So to the left
To the right.
is metals.
Take it.
To the right are non-metals. To the left is what?
Metals.
Except for
Oh, hold on.
an exception.
Ooh. Column 14.
What?
Hydrogen.
Oh, yeah.
Very nice.
That's one of your noble.
Hydrogen is the exception.
That's the same.
So hydrogen is a non-metal. Oxygen is a non-metal. You have hydrogen and oxygen bonded together. So what type of bond is this?
It's a covalent bond.
It's a covalent bond. And you can now give me more detail of what type of bond.
Polar.
Covalent.
Polar or covalent bond. So here's the thing, what's happening in this? It's that abusive relationship.
I still don't get how this
It's
relates.
the Bobby Brown to the Whitney.
I'm going to explain it.
What did you say?
It's the
I
Bobby
know
Brown
you didn't
to
say that, John.
We're gonna pretend that didn't happen.
I give music references, that's about it.
Tell them like you.
So you got oxygen here. So oxygen, you know, the stuff. Eat the stuff. Like swag central, alright?
Please don't say that, I already got.
Then he got his fine honey.
Well, she
I'm
ain't
number
too
one,
fine
I'm
with
number
me.
But then it ain't good enough, so he got another fine honey.
Oh,
He got one on the side.
I got something funny, but I'm holding the bag.
Thanks. So in this, what's happening is she's beautiful, she's gorgeous, joyful, has a great personality, wonderful. He gets with her, looks at her and goes, "Oh my God, you look ugly in yellow."
well,
Look at him saying, well, I bet you don't look good in yellow either.
Takes her out to the movies and is like, "Oh, let me see your purse. Yeah, you're paying for my popcorn." Don't name names.
That's toxic. I think I should put that. You guys were off at the bus. You guys like trying to say
Do not name names.
we just said a food, okay?
I
Yeah.
said a name, but
Talking
it's
to
okay.
food.
I'd hate to know how much editing you have to do.
Here's the thing. What are covalent bonds doing? They what
Sharing
electrons?
electrons.
Share electrons. But this is an unequal share. Polar bonds have an unequal share.
I think he's gonna say polar bears.
So the bully in the relationship, the abusive one, is the one that grabs a hold of that electron and holds on to it longer. It's kind of like the only time oxygen lets hydrogen have the electron so it can have the full outer shell is the moment whenever hydrogen's BFFs come in and was like, "You can do so much better, girl. Like, look at you. He's totally changed you." You're like, "You know what? You're right. I just need to drop him." I deserve better.
Therapy.
And then she walks down the hallway, and it's like you see the whole breakup thing happen, and then you see oxygen's like, "No, baby, I'm sorry. I got you a stone."
Right now.
And then she looks, and she comes back, and you're like, "How you doing?" It's like, "Oh, it's great. Like everything's working out now." What? I thought she was breaking up.
And then they break up
You
and
got
she
me
comes out with an album.
A diss track.
A Taylor Swift.
It's a diss track.
So this is what happens. There's an unequal sharing of electrons. What is an electron?
It's a negatively charged subatomic particle.
Negatively charged subatomic particle. I'm so proud of
Now
you.
you're just copying the
So the negatively charged subatomic particle means oxygen holds on to that negatively charged subatomic particle longer, which means it's adding that electron in more, which means it's adding a negative charge in more, which builds this partial negative region. Hydrogen doesn't get to have the electron that long, which means it's built this partial positive region. That's a Greek letter, lowercase, I think it's lowercase delta. Everybody freaks out on me. Another way we can symbolize this to show polarity within bonds is we can point an arrow from one atom to the other with the arrow pointing towards the negative region. So we'll come from the hydrogen and go to the oxygen, and then at the end we'll put a plus at the tail to show that this is the positive region. There's just two ways that we'll symbolize this. This is where everything comes in at, and this is where the whole world will change. The reason it'll change, draw some water molecules up here.
I'll actually pick the color for you. That makes sense.
I don't know, I've done it for a
Why
while.
are they screaming at me? Oh,
What you like, what
they reminds me of newspapers things. Elementary school,
That's like the worst class ever.
So here's the thing, here's what happens when you got a bunch of waters that stack up. They form something very special. What do opposites do? Exactly.
That's why you have two classes.
So what do you think a partial positive and a partial negative does? They attract each other. When they do this, they form this attraction.
and then they can think of the head of an
That attraction that you see me dotting there is something that should not throw you off guard. You should have heard about this.
Yeah, what
Like
cause?
gossip.
Yeah, cause the, wait, which one's the woman, the hydrogen?
Hydrogen.
Yeah, because she, oh my God, there's something real important with it, what is it? Oh my God, it has a warm bond? No. Oh, what was it in AP Bio that you?
Hydrogen bonding is an attractive force between hydrogens and a highly electronegative partially negative atom. In this case, it can change. Oxygen can change out to be something else, highly electronegative, that will attract and pull on those hydrogens. How many of you in this room, have you ever been cooking or in the kitchen or something, and you decide that you got a glass, well,
Wait, hurry, finish it.
and you try to pour water slowly out of the glass.
Oh my God. And the gravity, but.
Water will run to the back end of the glass and then fall off, right?
Because it's bonded.
The reason why is what is glass made of? What is sand?
Sand. Non-polar.
Silicon dioxide, which is a
Polar
polar
bond.
bond. Polar is attracted to polar. I will pick this up next Tuesday.
Yeah, we know.